Hello student, my name is Hitesh and you are watching my channel, Your Classroom at Home. If you really want to increase your mathematics skills, so please don't forget to subscribe my channel. In today's lecture student, we will discuss about number system. First of all, we will discuss natural number. Natural number started from 1, then 2, 3, 4 and so on. Next type of the number is whole number. Whole numbers started from 0, 0, 1, 2, 3, 4 and so on. Here we see that 1, 2, 3, 4 are also natural numbers. Important point is to be noted here. All natural numbers are whole numbers. But all whole numbers are not natural number. For example, 0 is a whole number. Which is not natural number. Integers are of three types. 0. 0 is neither positive nor negative. Then 1, 2, 3, 4 and so on. These are positive integers. Positive integers are to the right side of the 0. To the left side of 0 are negative integers. -1, -2, -3 and so on. Positive integers. Negative integers. Here we see that 1, 2, 3, 4 are also natural numbers. It means natural numbers are also included in integers. Here 0, 1, 2, 3 and 4 are whole numbers. It means whole numbers are also included in integers. Important point is to be noted here. All natural numbers and whole numbers are included in integers. It means all natural numbers and whole numbers are integers. Point number 2. All integers are not natural number and whole numbers. For example, -2 is an integer but not whole number and natural number. Now we will discuss rational number. Those numbers which can be written in the form of P upon Q, where P and Q are co-prime integers. And Q is not equals to 0. For example, 5 upon 2. Here 5 and 2 are co-prime integers. Let's try to understand co-prime integers. Those numbers which have no common factors other than 1. Co-prime integers means those numbers which have no common factor other than 1. So it means here 5 and 2 are co-prime integers since these numbers have only one common factor, that is 1. It means rational number will be in the form of fraction in which numerator and denominator are co-prime integers and denominator cannot be equals to 0. Why? P and Q must be co-prime integers and Q must not be equals to 0. Let's try to understand these points one by one. There are infinitely many numbers which are equivalent to each other. For example, if we take 5 by 2, equivalent of 5 by 2 will be 10 by 4, will be 15 by 6, will be 20 by 8 and so on. Here 5 and 2 we know very well are co-prime integers. 10 and 4 are not co-prime integers since these numbers have some common factor other than 1. Here both have two common factor here. Similarly, 15 by 6 are also not co-prime integers because 15 and 6 can easily be divided by 3. Similarly, these are also not co-prime integers. Suppose if we want to represent these numbers on number lines, then it is sufficient to represent 5 by 2. This is -1, 0, 1, 2 and 3. 5 by 2 means 2.5 which lie in the middle of 2 and 3. This is a point A which is equals to 5 by 2. In 5 by 2 all these numbers are included. So it means no need to represent these numbers separately on number lines. So we can say P and Q must be co-prime integers. Now we will discuss why the denominator or Q cannot be equals to 0. Let take an example 3 by 0. It is tends to infinity, and infinity is not equals to rational number. So we can say denominator cannot be 0, otherwise it will be tends to infinity. Rational number is the largest group among whole numbers, natural numbers, integers. Since natural number, whole numbers and integers are included in rational number. We know that natural number started from 1, then 2, 3, 4 and so on. Can these numbers be rational number? Yes, of course. Since 1 upon 1 is equals to 1. 2 can be equals to 2 by 1. 3 can also be equals to 3 by 1. 4 can also be equals to 4 by 1 and so on. It means these numbers are also in the form of P upon Q, and these numbers are co-prime integers. It means all natural numbers are rational numbers. Similarly, all whole numbers are included in rational number. For example, 0 upon 1 is also a rational number. 1 upon 1, 2 upon 1, 3 upon 1, these are also whole numbers, and whole numbers can also be in the form of rational number. Integers are also included in rational numbers. Integers are 0, 1, 2, 3 and so on, minus 1, minus 2 and so on. 0 can be expressed as 0 by 1. 1 can also be expressed as 1 upon 1. 2 can also be expressed as 2 upon 1 and so on. Similarly, minus 1 can also be expressed as minus 1 upon 1, minus 2 upon 1 and so on. It means these numbers are in the form of P upon Q, and P and Q are co-prime integers. Here 1 is not equals to 0. It means natural number, whole number and integers, all these numbers fulfill all requirements of rational number. So these are also the rational number. So important point is to be noted here. All natural numbers, whole numbers, and integers are rational numbers. But all rational numbers are not natural number whole numbers and integers. For example, 5 by 2 minus 5 upon 6, 3 upon 2, etc. are rational numbers. But these numbers are not natural numbers, whole numbers and integers. These important points can easily learn through Venn diagram. Let this is a set of natural numbers. Natural numbers are included in whole number. Whole numbers are included in integers. Integers are represented by z. And all these numbers are included in rational number, where n represent natural numbers. W represent whole numbers. Z represent integers. And Q represent rational number. Now we will discuss real numbers. Real numbers are of two types. One is rational number, which we have discussed earlier. Another type of the real numbers are irrational numbers. Now, define irrational number. The definition says those real numbers which are not rational number. For example, root 2, cube root of 3, cube root of 4, fourth root of 6, etc. Now we will try to understand rational and irrational number with the help of their decimal expansion. Decimal expansion form of rational number. Rational number have two types of decimal expansion. One is terminating decimals. For example, 11 upon 10 will equals to 1.1. Similarly, 7 upon 100 will equals to 0.07 and so on. Here we see that 1.1 is ended with 1. 0.07 is ended at 7. So it means these are some example of terminating decimal form of rational number. We can draw an important conclusion for terminating decimal expansion of rational number. Suppose a rational number which is in the form of P upon Q, where P and Q are co-prime integers and Q is not equals to 0, is terminating decimal if and only if denominator or Q has prime factors only 2 or only 5 or both only 2 and 5. For example, let 7 upon 4. Here 4 is denominator. Factor of 4 is 2 into 2. This fraction can easily be changed into decimal form without actually performing long division method. Let's watch it carefully. 7 upon 2 into 2. Multiply denominator by 25 as 5 into 5. For balancing it, multiply numerator also by 25. 25 7 ja 175. 10 10 ja 100. It means 1.75. So 7.4 is equals to 1.75, which is ended with digits 5. So it is terminating decimal since its factor of denominator is only 2. Illustrate it with one more example. Let there is a rational number 6 upon 15. The factor of 15 is 3 and 5. Now somebody think 6 upon 15 is non-terminating but repeating since it has extra factor 3, which is other than the factor of 2 and 5. But your answer will be incorrect since 6 and 15 has common factor 3. It means change this fraction into lowest form. 3 1 ja 3, 3 2 ja 6, 2 upon 5. 2 upon 5, it means here denominator has factor 5. It means this will be terminating decimal. 2 upon 5 multiply by 5 by 2. For balancing it, multiply numerator by 2. It means we will get 4 upon 10. That will be equals to 0.4. It is definitely a terminating decimal form of rational number. So student, before reaching on any conclusion whether the given rational number is terminating decimal form or non-terminating but repeating form, you have to change the given rational number into the lowest term. If still you get the factor of denominator is only 2 or 5 or both 2 and 5, it means your rational number is definitely terminating decimal, otherwise it will be non-terminating but repeating decimal form of rational number. Non-terminating but recurring or repeating. For example, 10 upon 3, which will be equals to 3.333 and dot dot dot. Or we can say this is 3 point bar on 3. Let's check it out. 3 3 is 9, 1 decimal 0. 3 3 is 9, further 1. It means at every time we will get the remainder 1. By using decimal, we can use infinitely times 0. It means at every time this 10 is divided by 3 times. In this way, we get 10 by 3 equals to 3.3333 and so on, which means 3 bar on 3. So this is an example of non-terminating but recurring decimal. Now we will discuss the decimal expansion of irrational number. 3.505005 0005 and so on. Here we see that there is no fixed pattern in after the decimal. Here we see 50, 5, 00, 5, 3 times 0, 5, 4 times 0 and so on. Some more Example of irrational number are 1, 23.71, 7, 1, 1, 7, 1, 1, 1, and so on. Similarly, 57.34, 3, 4, 4, 3, 4, 4, 4, and 3. It means all imperfect square root, imperfect cube root, imperfect fourth root are always non-terminating and non-repeating. For example, root 3 is equals to 1.732 and so on. After decimal, there will be no numbers will repeat. Or we can say there will be no fixed pattern will be found in these numbers. Pi is equals to 3.14 and dot dot dot. These numbers are also non-repeating and non-terminating. It means pi is an example of irrational number. Sometimes there is misconception among a student. Pi is equals to 22 upon 7. But pi is not equals to 22 upon 7. 22 upon 7 is approximate value of pi. Here we see that 22 upon 7 is rational number which is in the form of p upon q. Here p is 22 and 7 is q, which are already co-prime integers. Let's try to understand that pi is not equals to 22 upon 7. Pi is equals to 3.14159. This value of pi is correct up to 5 places of decimal. If we divide 22 by 7, let what result come out? 7 3 are 21. 1 decimal 0. 7 1 is 7. 3 0. 7 3 7 4 are 28. 2 0. 7 2 are 14. 6 0. 7 8 are 56. And 4. Here we see that the 22 upon 7 will equals to 3.1428. It means these two values are not same. Hence, pi is not equals to 22 upon 7. Sometimes one more misconception may be possible among a student. Somebody say root 3 is in the form of p upon q, which may be possible. This will be a rational number. But it is not a rational number, it is an irrational number. Since root 3 is not an integer, for rational number, p and q must be co-prime integers. But root 3 is here not an integer. So student, in today's lecture we have discussed different type of the number under the head of the topic number system. Whenever you come in class 11th, you will study another type of the number, that will be complex number, which you will learn in my upcoming lectures. So please keep watching my videos and keep practicing. Thank you. Take care.